Welcome to you in this lecture linear programming. All the lectures that we have do previously, they were the foundation of linear programming. Our main lecture start from here for the linear programming. But we have understand about inequalities and without understanding about inequalities it is difficult for us to start the linear programming. So it is quite hopeful for us that we are starting linear programming before doing all the basics. So hope you will understand this lecture, and let me start first of all what is linear programming. To define the linear programming, we need to define the objective function. We will define over here that what is objective function. Remember that a function which is to be minimize or maximize. Okay, a function which is to be minimize, or this is a function. And what type of function this is? A function which is to be minimize or maximize. To be minimize or maximize is called linear function. Is called linear is called objective function, not linear. This is called objective. Is called objective function. Okay, so any function, any mathematical functions, as we have already know that what is the definition of function. Remember that a function is a machine which gives an output value for each input value. Okay, so for any function which can be maximized or minimized, that function will be objective function. Now we will understand that what is optimal solution. Okay, so optimal solution is the feasible solution. Okay, the feasible solution. This is the feasible solution. Okay, this is the feasible solution which is to be maximized or minimized, which is to be minimize or maximize. Remember that we are talking about a feasible solution. A feasible solution is that solution which exists in the first quadrant, means that for x is positive and y is positive. So whenever there will be an example, just like as we have do many example in the previous lectures, whenever we will deal with the examples. Okay, the example of feasible solution. Suppose if there is example and that example contains optimal solution, find the optimal solution, then what does it mean by? It means that we want to find the feasible solution. Okay, so feasible solution means that the solution in the first quadrant. So now there is another theorem, and that theorem is called theorem of linear programming. So what is theorem of linear programming? Theorem of linear, the statement of theorem of linear programming is just like as yes. The theorem of linear programming states that the maximum and minimum value of objective function the maximum and minimum value the maximum and the minimum value of the objective function of the objective function occur at corner points occur at occur at corner occur at corner points of the feasible region occurs at the corner points of the feasible region. So the statement of theorem is also similar. It is also describing about maximum and minimum value. So the maximum and minimum value of the objective function, it occur at what point? It will occur at corner points. Okay, but remember that here the region is also feasible region. So whenever we will find the maximum value or the minimum value and the minimum value, then what we will do, we will find the corner points. Okay, find the corner points of the feasible region. Okay, if there is a function, and what kind of function, that function is objective function, and we want to find the value of objective function. What value? Maximum value or the minimum value of the objective function. Then we will find the corner points of the feasible region. Feasible region means that in the first quadrant. Okay, so this is the statement of the theorem of linear programming. Now method for the or procedure for determine optimal solution. So there are 3 to 4 steps that we will do in this procedure for determine optimal solution. The first is we will graph the solution. First is graph the solution. Graph the solution. Okay, solution set of graph the solution set of linear inequalities. Graph the solution set of linear inequality. This is our first, okay, to determine the feasible region. To determine the feasible region. region. Okay, this is the first point. The second is find the corner points of the feasible region. Find the corner points of the feasible find the corner points of the feasible region. Okay, so this is second step, and in the third step evaluate the objective function. Third is evaluate the objective function. Evaluate the objective function. Okay, at what point? At corner points. At corner points. Okay, to find the optimal solution. To find the optimal solution. Okay, so let me check again what are these points. The first is the graph the solution set of linear inequalities. As we have did our work how to graph the linear inequalities, lot of examples we have do previously. So lot of example we have done previously. What is that? It is linear inequalities to determine feasible regions. Of course we have to. Okay, the second thing, find the corner points. Yes, this practice we have also done in the previous lectures. Okay, find the corner points of the feasible region. Yes, and now evaluate the objective function at corner points. This is an additional work which is evaluate the objective function at corner points. Okay, so why we will evaluate the objective function for corner points? Yes, we will evaluate it to find the optimal solution. Okay, so to understand this theory we will do example. Okay, so let's move to this example. The example is find the maximum and minimum value of the function which is defined as. Okay, the function is defined as it is f of xy, f of x comma y, and this function is equal to, this is 2x plus 3y, 2x plus 3y subject to the constraint subjects to the constraints and the constraints are, first is it is x minus y, which is less than or equal to 2, and then x plus y. The second is it is x plus y, and x plus y is greater than or equal to 4. Okay, and third is 2x minus y, 2x minus y which is less than or equal to 6. Okay, and of course it is feasible region. Feasible region means that yes, that is x is greater than or equal to 0, x positive. Okay, so the given function, which is of course f of xy is equal to 2x plus 3y. Okay, so we will write the associated equation. The first is the associated equation. The associated equation the associated equations are just like these are: x minus y is equal to 2, and then x plus y which is equal to 4. Next is 2x minus y which is equal to 6, and of course x is equal to 0. X is equal to 0. Okay, so these are, if I write them, this is our equation number. Suppose this is 1 2 3, and if it is 4. Okay, yes, and let we name these 1 2 3 4, and this is of course, okay, let this is 1, and this is 2, and 3. Okay, and this is 4. Okay, so after this we will find the points. Okay, for x is equal to 0, for x is equal to 0 and 2. Okay, yes, for x is equal to 0 and 2, for x is equal to 0 in 1 we can write. Okay, for x is equal to 0 in 1, which means that y is equal to minus 2. This implies y is equal to minus 2. So our point is 0 comma minus 2. Okay, and for y is equal to 0, for y is equal to 0 in 1, we get x is equal to, in 1, x is equal to 2. X is equal to 2. So our point is 2 comma 0. Okay, 2 comma 0. This is our point, and if I combine this point, then this is 0 comma minus 2 and 2 comma 0. Okay, for line 1. Okay, yes, so now we will take the second line, and in the second line, for x is equal to 0. Yes, what is the second line? Okay, this is your second line. For x is equal to 0 in 2, x is equal to 0 in 2, we get y is equal to 4. So this means that our point is 0 comma 4. Okay, and in the similar way for y is equal to 0 in 2, for y is equal to 0 in 2, which means that x is equal to 4, x is equal to 4. So our point is 4 comma 0. Okay, and if I combine these 2 points, then it will be the points, the second points. Okay, 0 comma 4 and 4 comma 0. I will write this point over here. Okay, so let's write 0 comma 2, 0 comma it is 4, 0 comma 4. Okay, and the second point is 4 comma 0. Yes, this is our second point. Okay, now we find consider the line third. This is 2x minus y is equal to 6. Okay, and line third, for x is equal to for x is equal to 0 in 3, you can see for x is equal to 0 in 3, which means y is equal to minus 6, y is equal to minus 6. So our point is 0 comma minus 6. Okay, and for y is equal to 0, for y is equal to 0 in 3, which means 2x is equal to 6, so x is equal to 3, x is equal to 3. So our point is 3 comma 0, 3 comma 0. Okay, so if I write this point, then it will be just like as, okay, it is 0, the points of the third line is minus 6, okay, and 3 comma 0. Okay, so these are 2 points from which the line third pass. Okay, yes, now we'll draw these points, and we know that how to draw these points as we have already did the practice. Okay, so let me draw these points, and before drawing these points, okay, let's draw the axis, draw the axis, x-axis and y-axis. Okay, this is, so our points are, first of all, what our points are, check out the points. Our points are, you can see, these are 0 comma minus 2, this point 0 minus 2 and 2 0. Okay, 0 minus 2. Okay, 0 minus 2 will be over here. Okay, 0 minus 2 will be over here, and 2, it will be just like as this will be over here. Okay, this is minus 2 and this is 2. So it means that our line will pass from here. Let me draw the line. So line is not exactly passing. Once again we will draw the line. Approximately it is correct. Okay, so this is, so what happens over here? Yes, this is 2. Once again, okay, So now we take the next 2 points. The next 2 points are, okay, this is line, you can say this is your line 1. Okay, let I take this line 1, line 1. Okay, and to the points of line 2, which is 0, 4 and 4, 0, 0, 4, if just like if it is 2 over here, 2 over here, and 4 will be over here. Okay, similarly 2 is over, 2 is here, so this means that 4 over here. Okay, now we draw the line from this point. The line 2 will pass through these points. Okay, so a little bit array as I have already described that maybe. Okay, so this is 4 and this is approximately 2. It's okay. So now the third point is, our third point, you can see it is 0, minus 6 and 3, 0. Okay, so 0 minus 6 will be over here on this 0. So if it is minus 2 and this is minus 4 and this is minus 6. Okay, so 0 minus 6, 0, x is equal to 0, y is equal to, so no, x is equal to 0, x is equal to, yes, this is, if this is minus 2, this is minus 4, and of course this will be minus 6. Okay, 0 minus 6 and 0, 3, 0, 3. If this is 2, so this means that 3 will be over here, 3 will be over here. So our third line, remember that this is our second line, so our third line will pass through these 2 points. Okay, so let me pass the third line. When we pass the third line from these 2 points, it will be just like as, okay, so pass the third line from these 2 points. Once again select, yes, exactly. Okay, so this is our third line. Okay, so this means that first line, second line, and this is your third line. And if I once again write the inequalities, okay, the inequalities are x minus y, x minus y is less than or equal to 2, and x plus y which is less than or equal to 4, and the next is 2x minus y, 2x minus y, 2x minus y which is less than or equal to 6. So also x is positive, x is greater than or equal to 0. So here you will see that all these inequalities satisfy 0, 0. Okay, the test point, test point is 0, 0, test point which is equal to 0, 0, and when we put the test point in all these inequalities, it will satisfy. Okay, just like if I put x is equal to 0, y is equal to 0 over here, we will get 0 is less than or equal to 2, which is correct. If I put x is equal to 0, y is equal to 0 over here, then we get 0 is less than or equal to 4. In the similar way, for x is equal to 0 and y is equal to 0, we will get 0 is less than or equal to 6. Okay, so over here for x is positive, so this means that of course it is also true. So it means that these three lines, solution of these three lines is towards solution of these three lines, the first line, second line and third line. The solution of these lines are towards origin because they are satisfying the origin. Okay, when we talk about the first line, this is your first line. Okay, so its solution is towards origin, just like as. Okay, and when we talk about the second line, this is your second line, its solution is also towards origin, so this is your solution. Okay, towards origin. When we talk about the third line, this is your third line and its solution is also towards origin. Okay, it's also towards origin. And x is positive, x is greater than or equal to 0, means that x is greater than or equal to 0, means x is equal to 0 on y-axis. Y-axis is the line, this is y-axis is the line where x is greater than or equal to 0. Okay, so it means that this line contains its solution towards right. X is positive towards right. Okay, so you can see that since x is positive, you can see that which region is the common region. Actually we want to find the common region, which region is the common region. Okay, so we can say that, okay, yes, our common region, actually we want to find the common region. Okay, so for this, once again, if I will check that, maybe the inequality symbols are x minus y is less than, yes, so x plus y. Okay, I am checking either it is correct or not correct. X minus y, which is less than or equal to 2, x plus y, which is less than or equal to 4, and 2x minus y, which is less than or equal to 6. So this means that all the lines has their solutions towards origin. Remember that they have their solutions towards origin, and also x is positive. Okay, so if we increase this line, yes, this line, if we increase this line, so it is obvious that this line will meet three line. This is yes, first line, it will meet the first line at a point, and this is the point where it will meet. Okay, yes, so this means that the common region, okay, we actually want to find the common region. Okay, so our common region will be in all these cases for x. Okay, if the solution is towards origin, okay, this has its solutions toward origin, this line has also solutions toward origin. Okay, and yes, origin, and remember that this line has also solution towards origin. So the common from three lines, and x is positive, so this will be the region. Okay, remember that this is the region. Okay, I am shading this region. Yes, okay, it will be this is the region which is common region. Okay, so if this region is the common region, then we want to find the corner points. Okay, so these are the corner points. This is A, and of course this is O, and this point is B. Okay, A, O, B, and where this line meet, it is C. Okay, so these are the points. Okay, so what is point A? The point A is also given, which is x is equal to 0, 4. Okay, the point A, which is 0, 4, and the point B, okay, which will be 3, remember that's the point B. Okay, the point B is meeting on, yes, it is, remember that it is, yes, you can see over here, it is not meeting on 2, it is above. Okay, a little bit more, so it is actually the point of intersection. You can see that the point of intersection of line 2 and the point of intersection of line 3. Okay, point of intersection, you should know that how to find the, in the previous example we have do the how to find the point of intersection. Okay, so in line, second line and the first line, point of is the point of intersection of the second line and the first line is the point B, and this is can be find. Okay, it is 3, 3, 1, and in the similar way the point C, in the point C you can see that this is the point of intersection of the first line and the third line. Okay, yes, first line and third line, which can be find, okay, by simple by simple method, just like by comparing the variables. Okay, first acute the coefficient of the variable, then find the value of x and y, very simple. Okay, so this point of intersection is 4, 2. Okay, now our target is, remember that you can see that over here in this region, the solution region, there is no maximum value, there is no maximum value, because it is, this region is opening upward, this region is opening upward, so there is no maximum value, and of course this region has minimum value. Okay, so to find the minimum value we will write the function. Our function is, this was f of x, it is f of, which is given, f of xy, which is equal to 2x plus 3y. Now we will put these points A, B and C, and when we put point A, x is equal to 0, y is equal to 4, and after putting over here, okay, 2 into 0 plus 3 into 4, we get 12. Okay, in the similar way for the next point, which is 3, 1, put over here 3, 1, after putting it will be 2 into 3, okay, plus 3 into 1, and we get 6 plus 3, it is 9. Okay, in the similar way we will put the next point, which is f into 4, 2, which is equal to 2 into 4 plus 3 into 2, and it will be 6, it is 14. Okay, it is 14. So what is the minimum value? The minimum value is 9. You can check over here, the minimum value is 9. Okay, so the function has minimum value. Okay, thus minimum value we can write over here, thus minimum value of the function, minimum value of f of xy, f into x comma y is at the corner point, at the corner point is at the corner point, and that corner point is what it is? It is 3 comma b point, which is 3 comma 1. Okay, so it is in front of 1, remember. Okay, yes. This question has completed, and I hope that you will understand this question. You have understand these questions, how we have done this question. Okay, now we take another example, and this example is approximately similar to this example. Okay, but of course the constraints will be different. Okay, so what are the constraints which are different? The constraints are, the first of all functions. Here there are two functions. The first function is f into x comma y, which is equal to f into x comma y, and this is equal to 4x plus 5y, 4x plus 5y. And the second function is phi of x comma y, and this is equal to 4x plus 6y. And the constraints, these are the two functions. Okay, and the constraints corresponding to these functions are, which are 2x minus 3y. Okay, 2x minus 3y, which is less than or equal to 6, and 2x plus y, the second is 2x plus y is greater than or equal to 2, 2x plus y is greater than or equal to 2, and yes, 2x plus y and 2x plus 3y. The next is 2x plus 3y, and this is less than or equal to 12. Okay, and of course it is feasible region. The feasible region means that x is positive and y is positive. So these are the constraints subject to the functions. Okay, yes. Once again I will write it. Okay, so sorry for the time being paused. Okay, now these are the constraints, and we know that the associated, we write the associated equations. The associated equations are the associated equations. The associated equations are 2x minus 3y, and this is equal to 6. 2x plus y is equal to 2, and 2x plus 3y, 2x plus 3y is equal to 12. Okay, so these are the constraints. X is equal to 0 and y is equal to 0. Feasible region, which means first quadrant. Okay, and let we take the 2 points. See over here, what are the points? For x is equal to 0, for x is equal to 0, we will get 2x will be 0, so minus 3y is equal to 6, which means y is equal to minus 2. So our point is 0 comma minus 2. Okay, this is our first point. And the second point is, for y is equal to 0, we get 2x is equal to 6, which means x is equal to 3. Okay, so 3 comma 0 is our point. Okay, so this is the point. Okay, yes. So this is our point. Okay, now the second is, you can see over here, for x is equal to 0, y is equal to 2. So for x is equal to 0, y is equal to 2. In the similar way, for y is equal to 0, x is equal to 1. X is equal to 1 or y is equal to 0. Okay, so this means that this is our second yes, this is our second once again. If I will draw again, this will be just like S. Okay, and the third point, which is for x is equal to 0, for x is equal to 0, y is equal to 4. X is equal to 0, y is equal to 4. And in a similar way, for y is equal to, for x is equal to 0, y is equal to, for y is equal to 0, which means 2x is equal to 12, so x is equal to 6. So next point is 6 comma 0. Okay, so this will be the point. Okay, so these are the points. Now we want to draw these points. Okay, and we know that what is the procedure to draw these points. So first of all, we will draw the x and y coordinate system. After drawing the x and y coordinate system, okay, draw x-axis and y-axis. Yes, this is okay. The first point is 0 comma minus 2. 0 comma minus 2. This point will be over here. 0 comma yes, 0 comma minus 2. This point is 0 comma minus 2. Okay, and the next is 3 comma 0. So this point will be 3 comma 0. So it means that our first line will pass through here. So actually our software is not working well. Okay, I apologize if I am going slow. Okay, once again we will take the figure. Yes, we have selected it. Yes, this is So this is your point and this point. Okay, let this line is the first line, and now the point is, you can see 0 comma 2 and 1 comma 0, 0 comma 2 x 0 comma 2, which means this point will be over here, 0 comma 2 and 1 comma 0. 1 comma 0 means that it is 1 comma 0. So our next line will pass through so our software is totally not working. Apologize if it is. Yes, now this line will be just like as, yes, and the next is our third point is, it is passing through, you can see 0 comma 4, 0 comma 4, 0 comma 4 means that if this point is 2, so here it will be 4. Okay, this is 4. And 6 comma 0, 6 comma 0 means that if it is 3, so here it will be 6. Okay, so now next line will pass through these 2 points. Okay, let we draw the line from these 2 points. Okay, yes, correct. So once again, if we will check, it is, our solution region is the feasible region, x is the first quadrant only. Okay, if it is first quadrant, now we check that what are our points. Okay, so here we can see that if I put the point x is equal to 0 in this inequality, x is equal to 0, so this means that 0 is less than or equal to 6. In the similar way, if I put the point x is equal to 0, y is equal to 0 over here, so this means that 0 is greater than or equal to 2, and this is false. This is true and this is false. Okay, and if we put x is equal to 0, y is equal to 0 over here, test point, then it means that 0 is less than or equal to 12, and this is true. So it means that the first and third inequality, or you can say the first and third line, has its solution towards origin. Okay, while the second line, second inequality, has its solution region away from the origin. Solution region away from the origin. Okay, so first and third. So what is our first line? This was our first line, and this is your second line, and this is your third line. Okay, so first and 2x plus y, yes, 0. So first and third has its solution. The line first, this is your first line, and this is your third line. It has solutions towards origin. Towards origin means that towards origin. Okay, so when we talk about towards origin, then this means that our point will be away from, but the line third, which is your line third, second line is 2x plus y. This is your 2x plus y. The second line has its solutions away from the origin. Okay, so this is your second line. Okay, so second line, but in the first, remember that, but in the first quadrant, feasible region is the first quadrant. So away from, okay, we will first draw the solution of 1 in the first quadrant. Okay, this is your first line, this is first, and its solution in the first quadrant will be just like as, only in the first quadrant. We will not move away from first quadrant. Okay, Okay, and when we talk about the second line, okay, the second line has its solutions away from the origin, but in the first quadrant. Okay, away from the origin, but in the first quadrant. Okay, and now we check the third line. Okay, our third line has solution towards the origin, but in the first quadrant it will be just like as. Okay, so here this is your first corner point, and that this is A. Okay, and the second corner point, yes, this is your second corner point in the feasible region. Okay, and the third corner point, let this is C. Yes, this is C. Okay, and the fourth corner point, that this is D. Okay, and if we want to measure these points A, B, C and D, okay, we have already know that the point D is, okay, the point D is 0, 4, and the point A is, if you will see, the point A is, and this point can also be found by the intersections of the lines where they will intersect. Okay, so the point A is 1, 0, and the point B, which is 3, 0, and the point C. Okay, the point C, you can see where is point C. This is your point C. Okay, and this point is 4.5 approximately, which can be written as 9 by 2, 9 by 2, 1, and this point C can be found by the intersection of the first line and the intersection of the third line. Okay, and the point, yes, these are the 4 points. Also there is another point, which is the point E, and that point is 0. Okay, so yes, this is point E. This point is 0, 2. Okay, our next target is to find, okay, our next target is our function. The function given is f of x comma y. F of x comma y, this is equal to 4x plus 5y plus 5y. Now put the values over here, just like f of 1 comma 0, it will be equal to 5. Okay, 1 comma 0, which is equal to 4, and the next is f of 3 comma 0. In this case we get the answer 12, and f of 3 comma 0, 9 by 2 comma 1, in this case we will get the answer 23. Also f of 0 comma 4, in this case we will get answer 20. Okay, and f of 0 comma 2, we will get the answer 10. And from here you can see that f is maximum. Okay, here we can write f is maximum. The function f is max. F is max on which point? On which corner point? F is maximum on which corner point? The value, the 23 value is the biggest value, so 9 by 2 comma 1 is the point on 9 by 2 comma 1, and f is minimum. Okay, f is minimum, the lowest value is 4, therefore the point is 1 comma 0. Okay, now there were two functions, there were not only one functions. The second function is phi of x comma y, that was, yes, phi of x comma y, that is phi of x comma y, which was equal to 4x plus 6y, 4x plus 6y. Now putting the value phi of 1 comma 0, okay, the first value, which is 1 comma 0, we will get 4, and the next value, which is phi of 1 comma 0 and 3 comma 0. In this case we will get the answer 12, and phi of the next value is 9 by 2 comma 1, and this will be equal to 24, okay, and phi of 0 comma 4. In this case we will get, okay, the 0 comma 4, this is your 4 point, okay. In this case, when you will put 0 comma 4 in this function, you will get the answer, and this is equal to, after putting 0 comma 4, you will get 24. And in the similar way, after putting the next, yes, point 0 2, which is equal to 12. So you can conclude over here from that on which, yes, which is the maximum value and which is the minimum value. So see, yes, 24, okay, you can see there are 2 points, okay, on which the minimum value, if you will see, the minimum value is in this case is also 4, okay, the minimum value is 4. So at minimum value of phi is okay, so we can say minimum value of f into x comma y at what point? At the corner point 1 comma 0, okay, while the maximum value of is 24 at the corner points. There were 2 corner points, you can see, and the first corner point is 9 by 2 comma 11, okay, maximum value of this function at 2 points, which is 9 comma 2 11, yes, 1, and 0 comma 4, okay. So this is the way how to find, the maximum and minimum value at the corner points, okay. Hope you have understand about this example, and thank you very much for taking this course. I have put all my efforts to give the maximum, to give the 100% to my students. Thank you very much.